need to then try to identify if this falls within an AND solution or an OR solution, all right? And we said that if an absolute value of x is less than a real number a, all right, which is less than a real number a, which should be a positive integer, right? So that our distance between 0 and x becomes a positive value, right? So we say that if the absolute inequality of x less than a, then this implies that the solution will lie between the positive of our real number a and the negative of the real number a, right? And we said that this guy here is an AND solution, right? So it becomes a compound inequality. Then we then said that if the absolute value of x, which is the distance between 0 and x, which should be positive, if it's greater than our integer a, then this guy here becomes an OR solution, right? This becomes an OR solution. Then we'll have our first solution as x greater than a, which is just us looking into the given inequality and taking the first solution as the inequality given to us. Then we can then say, or x will be less than. Now we take the opposite of the inequality given to us. All right, so we'll then have our parameter x less than negative of our integer a there. Okay, so if we look into our example there, we notice that this is an OR solution, right? This is an OR solution of which we know that it will look like that. Okay, so we'll then take the inner quantity, which is the 2x, add by 4. We'll say this is greater than 8, or the 2x add by 4 is less than, you negate now the inequality there. And when you negate the inequality sign will then change. All right, it will then change and face the other side. So we have our negative 8 there. Right, so this then becomes a simple inequality, all right, a normal one. So we can just take the positive 4 to the right hand side. So we'll be left with 2x greater than your 8 minus 4, right? Your 8 minus 4, which becomes 2x greater than your 4. Then we want our variable x to be on the left hand side, but we have a coefficient which we need to get rid of. So we'll divide both sides by 2. All right. So if we divide both sides by 2, this then becomes what? This then becomes x greater than 2. Right. So what does this mean? It means that if we take any positive integer that is greater than 2 and substitute it within our inequality here, the result will always be greater than 8. All right. So let's just look into that, and let's say we have our absolute value of 2 into x. Let's say our x is 3, since 3 is greater than 2. So let's substitute 3 here, add by 4. So if we solve the inner quantity there, it becomes a product of 2 and 3, which becomes 6. Add by 4, then this becomes the absolute value of 10. And the absolute value of 10 is the same as the distance from 0 to 10, which is nothing but positive 10. and we notice that this positive 10 is greater than 8, so it satisfies the given inequality there. Okay, so that's how you check if your solution is correct, right? Then from there we can then look into the other inequality and try to solve it. So we'll do the very same thing. We take our positive 4 to the other side. So we have our 2x less than negative 8 and negative 4. So we'll then have our 2x. Okay, I'll continue writing the or there. Less than your 12. Then if you then try to solve or make the variable the subject of the inequality there, you'll then have your inequality as x less than negative 6. Right? So this implies that whatever value that is less than negative 6, if we substitute it within the given inequality there, the solution will always be greater than 8. Right? So let's just try to check that. So let's just take something which is less than negative 6. Say we have x equals to negative 100. Okay, let's just take this guy. So what we'll do is we'll try to substitute this given value of x within our inequality there, and we check the behavior of the inequality. So we have our 2 into negative 100 add by 4. So if we look into this will be 2 multiplied by negative 100. It becomes negative 200 add by 4. Okay, so from there we can then solve the inner quantity there. It becomes negative 200 add by 4. It becomes negative 196. And remember, we said that the absolute value of a given integer is just the distance from 0 to that particular integer. So if we then take the absolute value of negative 196, the solution becomes positive 196. And if we look into the given inequality there, it means that we'll have a scenario of 196 greater than 8, of which is true. Okay, then you can then start to celebrate and say, you know what, these inequalities, they satisfy the given absolute inequality there. All right, I hope that is clear.